to the Electricians 2 channel. Today I'm going to do a installation test using these installation testers before you. On the far left, if you're facing on your far left, would be the Ideal Industry 61-797 installation tester. This is their version. This is their higher end version of an installation tester by Ideal. Right here to the right of it is the Hioki IR4056 installation tester. Above it is the Fluke 1587 FC installation slash multimeter. Right here to the right of that would be the Extech MG300. Those of you guys who've been watching my videos, you've seen each one of these testers before. I've done a review on all of them. I even done installation tests. Perform installation tests with them. You may have seen these three before. You've seen this one. I haven't used this one much in any kind of comparison before, but I did have to do a video on it. Today I'm going to use it on this motor. I received this motor from a friend of mine. He who was just moved into his home, and this motor was on the shelf in the garage. He didn't know if it was good or bad. Just judging by the way it looked, he thought it was bad. He wanted to get rid of it without even using it. So I say, well, let me get it, and maybe I said myself I can put it in the video. This is a motor. It's made by Hayward Industries. It's a Century motor. It's a pool and spa motor. Model number 1081 pool pump duty. It's 1.5 horsepower, 115 volts, 15 amps, 60 hertz. They had the type SP, code H, installation class B. Single phase RPM is 3450. And remember, I said it's a single phase. I just want to test this motor, and just for the lack of time, I would have liked to done a PI test on it, polarization index test on it, but that would have been too long. If I had to do 10 on each, that would have been over 30 minutes, that would have been 40 minutes. On each phase, it's been longer than that. And I'm trying to stick to my own code. I don't like really long videos. I don't want to hold you guys, I just don't like long videos and to do long videos. So I'm going to do a PI test we're going to do a DAR test on using each one of these installation testers on this motor to see if it's good or bad. Now this is the kicker. I'm not going to tell you what I think, but I want you guys who view going to be viewing this video, leave your comment. You tell me if you think that it's bad or if it's good. And because I'm telling my friend, I'm gonna go back to him and let him know. I know what I think already. What I'm gonna think, but I'll answer you guys as you guys leave your comments. I want you guys to write in again. You guys to write in and leave your comments. You tell me by what's displayed on each one of these meters if this motor is bad or if it's good. We're gonna do a 1 minute. A 1 minute. 1 minute DAR test on each one. I'm gonna use this timer right here, so we'll know, because this one don't have a timer. The Fluke doesn't have a timer, and this doesn't have a timer. The only one that has a timer, a countdown timer, is the Ideal. So for the rest of them, I'm gonna use this 1 minute. I'm gonna use this this timer to let me know when the 1 minute is up. Okay, so I'm gonna start with Hioki. Start with that one, and I'm gonna put it on the neutral first, and I'm gonna do, since it's 115. Well, I'll tell you what I'm gonna do. I'm gonna put 1,000 volts in it. Let's go with 1,000 volts, and we're gonna do 1 minute. Okay, so here we go. Okay, let me know. Do that. Ground is in there. That is on there. Okay. Put your light on. That's 1,000 volts. It's on a neutral A. So you guys tell me, remember what you think. Now, this Hioki, it has a pass. It also displays pass and fail. When it passes, it stays this color. When it fails, the screen turns red. So far, it's reading pass. And I have them set to the minimum ratio. Using this one, it's going to go by this one that I have by the Fluke. It's going to tell me either 1 or 2 or 3 or 4, whatever. So I have it set on 2 right here because, all right, the 1660 on the neutral. I'm going to record that. 1660. Okay, that's the neutral mega ohms. Mega ohms at 1,000 volts. That's the neutral. Okay, now I'm gonna go to line in. Okay. Okay. So we're gonna start again. Leaving 1,000 volts. Went to the other leg. Okay, here we go. Okay. 1660 for the neutral. And this is the hot line. 1,000 volts. Okay. And I'm going to use the same set of test leads because I want the same reading. I don't want to use another pair of test leads. I want to use the same test leads and the same voltage. We're going to use the same through all the meters. Okay, 1710. And it says passed. Okay, 1710. That's on the hot. Where's my pen? Okay. 1710. Okay, I'm gonna go with the ideal. Let's take it over here. 1710 mega ohms. And it said passed. So okay. So what I'm going to do, I'm going to use, all right, I'm going to use 1,000 volts, and that means the compare should be at 100. Okay, so let me compare. Let me set it up. Let's show you what I'm doing is here. You can see. You're going to see the minimum ratio. So I'm going to put a 3, 4. It's 100, and that would be the passing according to the chart. There's a chart that I have over here. So we're going to do a DAR test. Okay, it's ready to go. All right. So if it passes, this green light gonna light up and let us know. Okay. So I'm ready to go. DAR 1,000 volts. Let's hit it. It's putting out an 800 K1 1426. And that's the hot. We're gonna do the hot first. Outside. The line side, I should say. Okay. Oh, I didn't pass that. I didn't press the button, but this has one. So we have 15 seconds left. 13 seconds. 7, 6, 5, 4, 3, 2, 1. Okay, it's showing me 1.0. If it would have passed, that would have lit up. So let me see, 1.0. 1.0, and according to this Fluke chart, 1.0 would be dangerous. So it's saying this the motor is bad. Now, if I'm reading correctly, this thing said it passed. The Hioki said that it passed. But according to this Fluke chart, it's saying that it says 1.0 on the DAR, right, the 60-second. Okay, and so it's saying that it failed. Okay, so I'm gonna put it on a neutral now, and we'll do the same test. Okay, here we go. 1,000 volts, ready to go. Remember, I want you guys to write in and you tell me what you think about this motor. Okay, let me get the time. 30 seconds left. Okay. That brings to mind, I'm going to do a video on it. This also, my last video was entitled Ideal Industries, Ideal versus Fluke. And I had in parentheses, they finally meet. Well, anyway, I did a review, and I did a little experiment when I was using the Amazon graphical multimeter. Let me finish. I'll tell you when I finish. This says 1.0 also, and that one was on a neutral. So according to this, again, let me see. I don't know if maybe the glare. It's saying that it's bad. Okay, that's 1.0, and that's a DAR test. Remember. All right, so let me tell you all about it when I finish this up that quick. I'm gonna bring the Extech down. Now, keep in mind the Extech doesn't have a PI test or a DAR. It does, but it does have a lock button, and it does have the lock button. Okay. Anyway, so I'm gonna put this at 1,000 volts also. 1,000 volts, and let me see if you guys can see this. And remember, I'm gonna use this timer right here for 1 minute, and we're gonna right now. Let me write it down. Extech. Extech. I'm going for 1,000 volts. This is the neutral. There you go. Okay, this is gonna be the I'm gonna get 1,000 volts also. Okay, so here we are. Hit the lock button. Okay, it's locked. Installation test. Okay. I don't know if you guys can see it really good, but let me give you a better look at it. There we go. 26 seconds left, and it's on the neutral to ground. Remember, I want you guys to leave a comment and tell me what you think. Which one of these testers is more accurate? What you think about the motor, if it's good or bad, or whatever. Okay? So I'm gonna stop that. It was 1790. Turned it off. Man, I gotta do it again because I didn't record the value. I gotta do it one more time. Turn it on too quickly. Okay. Range. Lock. 1 second. Okay. Here we go, 1,000 volts, because I didn't that's the neutral to ground. At 1,000 volts, that should have been over 2 mega ohms, so it's not. So just keep that in mind. I know you see it, but okay, 1748, and that's on the neutral. Okay, mega ohms. Okay, so now I'm okay, I'm gonna put it on hot, on the line, I should say. Okay. Go again with the range, go 1,000 volts. When I lock it, okay. Let's go for it. Okay. Oh, as I was saying earlier, I did an experiment, well, a little review, and I was using the the Fluke and the Extech that's with the top, and I pulled the Amazon graphical multimeter out just to be like a tiebreaker, and it was my fault, and it was brought to my attention by two of my viewers, Justin T, I call him JT, and another YouTube buddy of mine, Three Phase. That's the name of his channel. It's spelled out the letter three, and the word phase is spelled out. And they brought to my attention that the video was okay, but I was doing it wrong. Well, keep in mind, I am not, I've been an electrician for a long time, but sometimes I'm not always right. So what it was, I was using a receptacle as a test specimen, and I had the meter hooked up to the back of the receptacles. So what was going on, what I thought that was reading, from the receptacle, it was a reading from the meter, which would have been 10 mega ohms. And let me just stop this for a minute, and I'll get right back to you again. 1743, 1744. 1744. Okay. And anyway, it was reading the mega ohms that was from the multimeter, and I was thinking that it was reading the receptacle. And after I did it, and Justin, he told me about it. JT, he mentioned to me what was happening. So I went right back and I did the same experiment without the multimeter hooked up to the receptacle, and I got a different reading. So what he was telling me was absolutely right. I was wrong. I was doing a good review, but I was reading wrong. So with that being said, man, if y'all take a look at that video, it's entitled "Ideal versus Fluke. Finally, they meet." Don't be misled by it. Don't be misled by it. It just goes to show you that you could be wrong. I was wrong on that, and I take all responsibility. I'm thinking about taking it down. It was a pretty good video, and I think that's what I'm going to do, is take it down and do the whole thing over again. So, just to bring that out, and I'm gonna do that video again. And this time I will point this out, what I'm saying, what had happened. So, if you go back and look at that video and you see what I'm talking about, and you see the measurements that's coming up on the installation testers, that's from the multimeters, not the receptacle. So, and I thought it was a receptacle, but after they explained, JT and Three Phase explained it to me, I got what they were saying, and I was reading it wrong. Well, let me just carry on with this test that I'm doing. So we'll talk about that when I do the video again. All right, so now let me do the Fluke right now. So we got that. Okay. Okay. All right, the big bad Fluke. Here we go. And just to make it more interesting, I'm gonna put the Fluke connector on so we can see the graph. And we can see. Let me get it set up here. Okay. Bear 1 second. Let me get it together and connect the two. Put it right here so you guys can see it. Let me connect them. this over some. In fact, let me get this out of the way. So, and we'll check out the Fluke and see what it has to say. And put it on 1,000 volts. And thousand volts, and we can watch the graph. Here we go. Here we go, and this is on the line. All right. Here we go. DAR test. Go for it. I see it. Okay. 1.6. Nope. 1.7. 1.7. Put neutral. Okay, let's try the neutral. Okay. Here we go, 1,000 volts. And what I want to do, just for giggles and laughs, after I finish this up, I'm going to do a PI test with the Fluke, and we can see the graph, and we'll see just how it performed. This motor performs with that. It's not giving us a 2 mega ohms, over 2 mega ohms, so I'm gonna just say that the motor is bad. It's bad. It's bad. It's an installation problem. If you agree with me, leave a comment. If you don't, leave another comment. We could discuss it. Tell me where I'm wrong at, because I'm not always right. So tell me where I'm wrong if you think I'm wrong. But I'm going what I think is bad. Saying 1.0. Let's say 1.0 on the neutral. Okay, now I'm gonna do a PI test. If you do a PI test, and that's on the neutral, it's gonna be 10 minutes, fellas. If you got the time, check it out. If not, watch some now, watch some later. Here we go. A PI at 1,000 volts, and we'll watch how it breaks down, if this motor is bad or not. It would have been really nice if this Fluke would have had a timer on it. The Fluke 1507 has a timer. And I also like the pass or fail indication button on the Fluke 1507, but you know, but it doesn't have Fluke Connect on the 1507. So that's why I opted out and got this one. And speaking of the Fluke Connect, I was messing around with it last night, seeing all the features. Fluke have one of the best software as far as Bluetooth software out there. It's made for the professional. Trust me, they have so much. It's so much in there. And I know other people, Mega, Extech, all of them, they have their little Bluetooth, software on that you can link to and print out data. But Fluke is strictly for the professional. Extech, I never really seen theirs before. I never seen. I've seen. No, I seen one by Extech. I didn't think it was all that. I never seen Extech and Fluke and Ideal. I've seen those, and it can't compare to Fluke. That's just my opinion. I think the Fluke got it. As far as that's concerned. Well, I can't tell you how many minutes we have left because I didn't set a timer or anything. But I think this test's been running for at least about 3 minutes, maybe 4. So it's charging up. I see you have 1.9 mega ohms. No, giga ohms. So that doesn't mean anything. I guess when the test is over, we'll see the final measurement. Okay. Look at that. Okay. The update, I'm looking at the update speed from the Fluke and from this, the Fluke Connect. It's spot on too. It's really fast. I'm looking at both of them. And just as soon as this changed, I could kind of look from the side of my view, and this changed right with it, man. I don't know, maybe because it's so close, but it's really fast too, and it's accurate. Okay. So let me look at this chart. So that'll be 10-minute test. We'll see in a minute. If we had to base it upon what we see right now, 2 gigaohms, it would be good according to this. At a 10-minute polarization index test, it'll be good if we had to go by that. But we have to wait till the test finished for the final measurement. Then we have about 3 minutes left. Okay, let's say 1.2. The test is finished. 1.2. And a PI test. 1.2. PI test. Fluke. 1,000 volts. Now I'm gonna let you guys check out the reading. Now, let me get this out of the way. Okay. according to this chart right here, if you guys, some of you guys can see it. Let me make sure you guys can see it. I hope you can. It might be too far. All right. Right here. Let's try to put this way. Here. Anyway, according to this chart, I don't know if you can see it. Take a look at this chart right here. And here we go. The Hioki says that it was 1660 mega ohms on the neutral, 1710 on the hot. So that we will say 1.6 on the neutral, and 1.6 here. If it was 1.6, that would be and above. That would be excellent. Okay, according to this Fluke chart, and that's what the that's the DAR test, 60-30 seconds. That will be good. Now, the ideal gave us 1.0, the DAR test. And according to 1.0, the DAR test, that would be dangerous, meaning bad. That was on both legs. The Extech gave us 1748, 1744, so that'll be 1.7, which would be 1.6 and above. That would be excellent. Okay, now the Fluke has given us on the hot. The Fluke has given us on the line side 1.7, and on the neutral 1.0. So it's 1.0. 1.0 meaning it's bad. That's the neutral. So evidently the neutral is bad. It's going, and there's problem with the neutral. And 1.0. And I'm sorry, 1.7 on the line side. So it's saying it's excellent. And the polarization index test is 1.0. The PI test, same thing, 1.2 at 1,000 volts. 1.2. That'll put me right here. Okay, in between there. So it's saying it's poor. Y'all take a look at this. Y'all saw the test. Take a look at what I just wrote. I hope you know, it's kind of, this is the PI test, at the last one I did with the Fluke. At 1,000 volts, it gave me 1.2, 1.7 for the hot side, 1.0 for the neutral, and you see the rest. So you guys take a look at that, and leave your comments and tell me what you think about this motor. I think it's bad. Okay? So you let me know what you guys think. With that being said, man, thank you. Peace out. Take care. And I'll be waiting to hear from you guys later.